Hi, my name is Cal Mitchell, and this is my entry into the SingleStore Hackathon Hybrid Transaction Analytical Processing category. The name of my project is Reserva, an open source central bank digital currency with a fully functional REST API on top of the SingleStore database. The purpose of the project was to prove that SingleStore can run a high performance transactional workload while keeping key data in a column store table for analytical purposes. If you're interested, you can read more about the project in the linked blog post, but for now, let's get to setup instructions.
First, we need to clone the Git repository, open it with a text editor, and create a file called .envarc to hold environment variables. Paste in these values here. Now let's fill in the SingleStore license value, which can be found in the customer portal under self-managed licenses, and load these variables into our shell by running source.envarc. Next, we need to start the services defined in the Docker Compose file. This will start SingleStore, a key value cache for authentication tokens, Reserva itself, along with a custom load testing program. Once the services are running, we need to migrate our database schema. Go to localhost 8080 in your browser and log in with the credentials root and mypass123. Go to the SQL editor and create the Reserva database. Navigate away from that page and come back to it to get the Reserva database to show up in this list. Now let's migrate our schema by running these create table statements. We're almost done. We just need to add our first bank to the system, which we can do with this command. Now that we have our database migrated and have inserted our first bank, let's run the API with this command and take a short tour of the API. This command will get us an authentication token that allows us to make requests as the admin bank that we just created. Let's run this command to create another non-admin bank. I'll call it typical bank. Let's get an authentication token for typical bank and open an account that they control. At this point, we have two banks and have opened an account. Feel free to check out the blog post and project README to learn more about the API. Since we're short on time, let's skip ahead to load testing Reserva. To start the load testing application, open a new shell and execute this command. This program will populate the SingleStore database with a few banks, 1,000 accounts, and then start making transfers between those accounts as fast as your system can handle. The point of this project is to showcase Reserva's hybrid transactional analytical processing ability. So let's run an analytical query on the transfers table, which is a column store, while load testing is underway. Copy this query, which selects the accounts that are making the most transfers, and run it in SingleStore Studio. As you can see, the query runs with low latency even though our system is being totally maxed out by creating new transfers. This is very impressive, and anyone who wants to run a central bank digital currency for real would definitely appreciate being able to run analytical queries on their live data with no data engineering. Okay, the load testing is complete, and it looks like we were able to make 100,000 transfers in 42 seconds, or a rate of about 2,400 per second. This is very impressive performance, considering this is just running on my MacBook Air while running analytical queries and with other resource-intensive services running in parallel. This workload would definitely be a lot faster if we ran it in SingleStore's managed cloud. All right, that's my project. I hope you've enjoyed learning about it. Please contact me if you have any questions. Goodbye.